Okay, good afternoon all. From last few lectures are discussing related to the concept of powder metallurgy, and in that we have completed the concept of powder. What is the meaning of powder metallurgy? Then we have discussed various steps which are involved in the manufacturing of a component using the powder metallurgy technique. And then after that we have discussed different methods of manufacturing the powders. Then we have learned or we have seen how to manufacture three different components using this powder metallurgy powder metallurgy technique. In that we have discussed these self-lubricating bearing and then friction material and cemented carbide cutting tools along with the flow chart. Okay, we have seen the different stages involved in the manufacturing of that component using powder metallurgy technique. Then we have seen the how to draw the flow chart for each component. Okay, then after that, this is the last point from this chapter. That is, what are the advantages of the powder metallurgy technique? What are the advantages? Then what are the disadvantages? And after that, we are going to discuss about the applications, brief applications of this powder metallurgy technique. Okay, then we will start with the first point, that is the advantages. Now, lots of advantages are there for this powder metallurgy technique. And first advantage, you can go to this slide also. The first advantage is using this powder metallurgy technique, we can manufacture a component consisting of metal plus metal composition. Okay, components may consist of metal plus metal component, or we can also manufacture the component which consists of metal plus non-metal. Okay, in this powder metallurgy technique, this is the unique advantage of this method. That is, you can manufacture a component which consists of metal and metal plus metal, or you can manufacture a component which consists of metal plus non-metal. Okay, and you can manufacture that component with any desired composition. You can take any desired composition according to your need, according to the properties needed. You can choose the composition and you can choose its elements. It may be metal or it may be non-metal. And here also one more advantage is that you cannot, there is no means no need to refer any equilibrium diagram or phase diagram. Okay, directly you can go for the manufacturing of the component with your desired composition and desired powders. Okay, or powders, or you can say that desired metals or non-metal content which you want in your actual component or final component. There is no need to refer any phase diagram or equilibrium diagram like we have seen in the heat treatment, or you can say that in the various ferrous alloys or non-ferrous alloys. Then in the heat treatment process, we have to refer various equilibrium diagrams, get to do any kind of the changes. But here there is no need to refer any kind of the phase diagrams, and you can choose any metal composition or any metal plus non-metal composition to manufacture your component. This is the unique advantage. Then the next advantage is, if you can refer this third point. Whether my presentation is visible? Hello? Is there any problem? I was not able to see that.
So screen is not visible.
Kindly provide me reply. Wait. I have to start this go to meeting. Wait for a few minutes. Some network issue is here. Internet is not available on my PC. Wait, I will connect it to other device. Wait for a few minutes. I will get connected within 1 minute. I must wait. I'll just share the presentation. Please check it whether it is visible and provide me reply whether that is presentation or slides are visible now.
Yes, sir, it's visible now.
Okay, we will start. Okay, sorry for this inconvenience. Okay, due to some network issues, I got disconnected. Okay, now we will start again. Okay, now in this lecture we are going to complete this part. There's advantages, disadvantages of powder metallurgy technique, and after that we are going to discuss in brief related to the applications of the powder metallurgy technique. Now we have already started the advantages. Now we have discussed that you can manufacture any component which consists of compositions of metal plus metals or metal plus non-metals in any desired amount, or you can say that any desired composition of these metals and non-metals. Without referring to their equilibrium diagram, we can directly go for manufacturing of the component. Okay. Then after that, the next advantage is, you can see the third point in this slide, that is the controlled porosity can be obtained. Okay, you can control the porosity, amount of the porosity you can control in this powder metallurgy technique. And we have already discussed one component related to this. You can say that the a self-lubricating bearing, you can manufacture a self-lubricating bearing or lubricate a bearing which is having 30 to 50% amount of the porosity, and in that you can use that porosity of that component to fill the large quantity of oil or oil as per your requirement in that bearing, and that bearing can act as a self-lubricating bearing. Okay, means due to this controlled porosity, you can, depending on your need, you can change the porosity of that component, and you can increase its desired properties in that component. In short, you can write that you can get the controlled porosity in the component as per your need. Then the next advantage is that using this powder metallurgy technique, you can manufacture a component which is having, or whichever product you are manufacturing, you can carry forward whichever the properties of that parent metal, you can get that properties in your final product if you want. Okay, means whichever properties are there, suppose some electrical conductivity properties there in some of your metals like copper, like that, then you can get the same property in your final product also. Okay, because whenever, suppose you are manufacturing a component by your traditional techniques like casting, forming, or any other forging methods, then there may be some changes in the properties. Okay, the parent material property may not get forwarded into the final product. But here, this is the very good advantage of this powder metallurgy technique, that the properties of the parent metal, you can get that properties of parent metal in the final product also. Okay, and next advantage is, whichever refractory metals are there. Okay, refractory metals are there like tungsten, molybdenum, titanium. These are the refractory metals. Okay, and these refractory metals are having very high melting point. Some metals are having melting point above 2000 degrees Celsius or 2500 degrees Celsius also. Then it is almost impossible to manufacture these refractory metals by any other method. Then you can use the powder metallurgy technique here. Then you can refer this point, you can observe this where I am pointing. You can manufacture cemented carbide cutting tools, or some diamond impregnated tools are there. Okay, these tools which consist of refractory metals that can only be manufactured with the help of this powder metallurgy technique. Okay, You can manufacture these with the help of this powder metallurgy technique. Then the next advantage is please try to identify this pointer which I am highlighting here. The components from which okay. Now, okay, we will move forward. This point, please try to observe this point or read this point along with me. Now, the components from metals which are completely insoluble in each other in the liquid state, that type of components can also be manufactured in this powder metallurgy. Okay, the components which are completely insoluble in each other, you can manufacture the components which consists of that metals or that metals plus non-metals. Okay, you can manufacture that component also here. You can manufacture a component in such a way that it will consist of layers. You can go through these points. Means you manufacture a component which is having different layers, one layer of metal, then one layer of non-metal. Like that, you can manufacture that component. Means that there may be a metallic base, okay, non-metallic components, and there will be a metallic base. You can manufacture the component, or layers. You can manufacture one layer of metal, then one layer of non-metal, then again metal, non-metal, like this. Component which consists of the metallic, non-metallic layers, that component can be manufactured with the help of this powder metallurgy. The next slide. Now here, due to this powder metallurgy technique, very little chance of contamination will be there. Means whichever manufactured product will be there, that product will get with the very high purity. Okay, there will not be any contamination from any dust, oil particles or dust particles. They may not get trapped in your final component or final product. Then the next point, this is the powder metallurgy components. On the powder metallurgy components, you can easily perform further any heat treatment process, or you can say that any further operations like welding, brazing, machining, or you go for any type of the heat treatment process, any type of infiltration or impregnation process that can be performed on that component very easily. And next point is, manufacturing with this powder metallurgy technique, that component will get with the desired shape and size. Say that very close control on that dimensions can be done here in this powder metallurgy technique. Okay, easily you can control the dimensions of your component. Then the manufacture, it does not generally it does not require any further finishing or machining operation. Sometimes you have to done it, but very minimum finishing or machining operations are required. Hence, the scrap or wastage of the material will be very minimum. Okay, very minimum scrap will be there, or very minimum wastage of the material will be there in this process. Okay. This process, and generally you have to, whenever you are using this process, you have to go for simple shaped components. Okay, the simple shaped components, and you can go for the power. You can say that the mass scale or mass production of that component. When you go for mass production of the simple shaped components with the help of this powder metallurgy technique, this method will be very economical. Okay, provide conditions that which you should go for the mass production. Okay, one more point, while studying the disadvantages point, you can add more point related to this the economical aspect of this powder metallurgy method. This powder method is economical only when you are using it for simple shaped components and whenever you are doing mass production. If you are not doing the mass production, suppose you are manufacturing the components on the small scale, okay, some selling am I audible?
Sir, your voice is not properly audible.
I don't know the reason. I'm not using the headphones, and I have checked all the settings of my mobile phone also. Still, you are facing this same problem?
Yes, sir.
Okay. We are on now, the is will result in cost and it will more right the point in time. Whenever you are doing the means question on this the process is economical, high cost of the tooling or equipment will be very high. And the next point is no need to use any highly qualified or highly skilled work requires. And next you can write the few name of the component. This composite products, different kind of the composite products you can manufacture with the help of this powder metallurgy technique and different dispersion hardened materials. Okay, and these will come composites and dispersion materials. These will come in the you can say that we have already discussed this the different types of the composites, or you can simply write that different types of the composites materials having different composition you can manufacture with the help of this powder metallurgy technique. Then whichever we have manufactured some kind of the powders, and that powders or you can go for, or these powders have applications in the different kinds of the painting or in the paint industry. Then you can use it for the pyrotechnic methods. Then in the explosive, this pyrotechnic is nothing but the manufacturing of the different powders or different kinds of the materials which will burn, and while burning they will emit the light, high amount of the light. Okay, for different location devices this can be used, these pyrotechnics can be used. Then different kinds of the explosives, different kinds of the plastic, this RCC again it will come in the composite material. Different in short you can say that different kinds of the composite materials can be manufactured with the help of this powder metallurgy technique with desired component very easily. Okay, so these are approximately 10, 15, 16 advantages for metallurgy technique. Then we'll move towards the disadvantages of this powder metallurgy technique. Okay, say now we will start first disadvantage. Now, whichever powders we are manufacturing, suppose we have manufactured the powders like magnesium, then aluminium, titanium. These these powders, when come in contact with air, they will get oxidized down. There may be chances of explosion. Okay, and so to avoid this explosion and hazards related to this explosion, you have to take proper care manufacturing the component, and means whichever steps are there, you have to take proper control. So so that you will be able to avoid these kinds of the erosion and hazards related to these processes. First, you have to take care of that, avoid the oxidation of powders so that they not result in the corrosion. Okay. Before disadvantage, you have proper years related to the if which are used is only you manufacture the because it high investment in tool and equipment. That's why it is only suitable for mass production. Okay. Next disadvantage is that for large sized component or components or complex shaped component that is but the type of component is that size of the not possible to measure that component with the help of this powder metallurgy technique. The next disadvantage is that whichever powder metallurgy you have manufactured, you can see this point. Okay, like that component will have inferior properties. Okay, inferior when you manufactured with help of traditional method like or we have used, and suppose this component is manufactured with the help of powder metal technique, and if you do the comparison of the tensile strength or any other properties like hardness and corrosion resistance, wear resistance, then you will find that these powder metallurgy components are having some of the powder metallurgy components manufactured will show you superior properties. You can manufacture this having good properties or traditions like casting. You can go for different operations. Okay. And next, whichever theoretical density values are in the component, theoretical density value cannot be obtained in this particular technique. This is that is the theoretical density values can be obtained. Then this point already I have explained. Whichever ductility, tensile strength, toughness, or hardness values are there, or hardness properties are there. I'm not getting it. Still, my voice is not audible. Kindly check it. I'm doing all the resolutions from my side, but some students are still facing the voice problem. Okay. Whether it is clear or not. Continue. Not getting why the voice is not. Okay, wait, I will rejoin this. Rejoin it. Okay, don't leave the session. I will rejoin. Hello. Am I audible now? Okay. Okay, I will continue then. Okay, we are here now. The disadvantages of this powder metallurgy technique. Now, these two disadvantages, last two or three disadvantages are only related to the properties of the component. Means related to the properties like that. We will get whichever component is manufactured with the help of powder metallurgy technique. It will be, we are not getting that product with the desired particle density values. Then it will be having inferior properties like tensile strength, ductility, toughness, hardness. These values will be inferior compared to the same product manufactured with the help of conventional methods like casting, forging, or forming methods. Okay, and whichever surface finish of the components is obtained, that will be very. You can say that the poor surface finish will be obtained with the help of this powder metallurgy technique. So these are the various disadvantages of the powder metallurgy technique. Then after completing the discussion related to the advantages and disadvantages, we will move towards the next point, that is the applications of the powder metallurgy technique. Okay. Here I have taken the applications sector wise. Okay, first applications will be there. In the first, we have to write the applications related to the automotive sector. You can say that, or automobile sector, then defense sector, then atomic energy sector, and remaining some aerospace applications will be there. High temperature applications will be there, and remaining applications I have taken commonly in the other applications. Okay, then we will discuss one by one. In the automobile field, okay, as we have discussed this point in very brief, that we can manufacture the self lubricating bearing or porous bearing with the help of this powder metallurgy technique. Now, whichever that porous bearing is manufactured, that you can use, it can be used in the starters, wipers, then sliding doors are there, then different clutches, brakes are there in different automobile vehicles. It may be a car, bus, or it may be a truck, or it may be a tractor. Okay, these different, whichever these parts or components are there, in that component bearings are required, and that bearings are porous bearings, and these porous bearings are manufactured with the help of powder metallurgy technique only. Then next component you can manufacture is the sintered gear, and this sintered gear can be manufactured with the help of powder metallurgy process. And this sintered gear you can use in the different automobile vehicles. It may be car, then it may be a bus, trucks, or tractors. Okay, this sintered gear you can use there. Then you can manufacture the friction material also. This friction material is also known as sintered friction materials, and these friction materials you can use in the brakes, and that brake can be used in the different automobile vehicles. Okay, then you can manufacture other different components which can be very helpful in the automobile sector, like you can manufacture the crankshaft drive, then piston rings, then connecting rods, then brake lining, or different electrical contact components are there, or electrical contact material is there. These all can be manufactured with the help of this powder metallurgy technique, and these all components are very useful in the automobile sector. Okay, then next is the application of this powder metallurgy technique in the defense industry. Okay, now whichever different metal powders can be manufactured with the help of this powder metallurgy techniques, and that metal powders you can use that metal powders in the manufacturing of these components, which are very helpful in the rockets and missiles. You can manufacture different components. Okay, and you can say that the different cartridge cases are there, or directly the different kinds of the bullets having different composition or containing different powders. that can be manufactured with the help of this powder metallurgy techniques. Then different military pyrotechnics are there, like the tracers, trace the locations. Okay, for that you can use the manufacturing of that particular component or particular powder will be used for that pyrotechnic method that can be manufactured with the help of this powder metallurgy technique. Okay, in short you can say that the different devices or components are there, like rockets, missiles, cartridge cases or bullets, and they require certain metal powder, and that metal powder is manufactured with the help of this powder metallurgy technique. Then the next application is from the atomic energy sector. Okay, now whichever atomic energy sector is there, now the in that atomic energy sector different composite materials are used. Okay, different composite materials are used as the fuel in that atomic energy sector, or as a material to manufacture their different components. Okay, different components, like you can, we will see one by one here. Now composite materials you can use as a fuel elements. Okay, you can directly use them as a fuel elements. Then the different dispersion strengthened materials are there. Okay, these dispersion strengthened materials are nothing but your one of the type of the composite materials, and these can be used in the atomic reactors. Then high temperature gas turbines are there, and different computers are there. Okay, or different magneto-hydrodynamic generators are there. In that you can use this dispersion strengthened material. Directly you can write that the dispersion strengthened material, which is having wide applications in the atomic energy sector, that can be manufactured with the help of this powder metallurgy technique only. Okay, then beryllium zirconium metal powders are there. Now these beryllium zirconium metal powders are used in the control rods, then radiation reactors. Okay, different types of the control rods are there, and different types of in the radiation reactors you can use these metal powders. Then zirconium metal is there, metal powder is there, that can be used in the, used as a cladding material. Okay, cladding is nothing but just you are going to provide one layer. It is very similar operation to the coating. Okay, in short you can understand that it is very much similar to the coating, that just you are providing one layer on the parent metal, you are giving a small layer which is having better corrosion resistance or hardness properties. Then that material here commonly used is zirconium. Then the beryllium can be manufactured, you can use that beryllium as a moderator in the nuclear reactors. Then uranium oxide dispersion strengthened stainless steel material is there, that can be used as a fuel element. Now if you are not able to remember the specific names, you can directly write that in the atomic energy sector the powder metallurgy technique can be used. Powder metallurgy technique, some components manufactured from this technique, and its some powders can be used as fuel elements, and for manufacturing of the different components that can be used in the atomic energy sector. In short you can write like this also. Then some other applications are there, like you are having different devices with you, like your typewriter. Old in the older days typewriters are used, that typewriters, then timing devices are there, or different parts which are very useful in the clocks, or your calculators are there. Then different types of the permanent magnets are there, or some laminated bimetallic strips are there. All these components can be manufactured with the help of this powder metallurgy technique only. Okay, then we'll move towards the next slide. Okay, now we have two more sectors, that is high temperature applications and aerospace applications. Okay, in high temperature applications, say in short, or you can remember this, high temperature applications means your refractory metals like tungsten, molybdenum, titanium, thorium. All these refractory metals and their carbides, respective carbides, you can use it for the high temperature services, because they are having very high melting point, and all these refractory metals and their respective carbides can manufactured with the help of this powder metallurgy technique. Okay, then these refractory metals can be used for manufacturing of the different dyes. Then different cutting tools are there, different types of dies, rolls, cutting tools, and these can be used for high temperature applications. That can be, these are all manufactured with the help of this powder metallurgy technique only. Okay, now these refractory metals, you can easily understand that in your electric light bulbs, some filament is there. That filament is manufactured with the help of this tungsten or molybdenum. Okay, then some fluorescent tubes are there, then radio walls, then your different x-ray tubes are there, and all these components in the form of filament or in the form of cathode, anode, or in the form of some screen or in the form of some control grids. Okay, all these refractory metals are only used there. Okay, these refractory metals are used there. Okay, these are high temperature application. Then some aerospace applications are there. In the aerospace, you can say that the different powders manufactured like beryllium, aluminium, magnesium, then zircon, all these powders are used as a solid fuel in the rockets and missiles. Okay, aluminium, beryllium, magnesium, zirconium, all these powders are used as a solid fuel in the different rockets and missiles. Then in the aerospace technique only, the different kinds of the, in the plasma jet engines or ion engine is there, and that different components are required. That components are manufactured with the help of this powder metallurgy technique only. Then different kinds of the bronze bearings, then filters and ferrite cores of the, for the transformers and inductor coils, and different kinds of the magnetic materials are there. And all these bearings, filters, then transformers and magnetic materials are used in the whichever satellites are there or space vehicles are there. These are used in that field, or you can say that in the aerospace applications. And all these can be manufactured with the help of this powder metallurgy technique only. Okay, so these are the different applications of this powder metallurgy technique. Okay, we have discussed related to the automobile sector application and defense sector application, atomic energy applications, then some high temperature applications, then aerospace sector applications, and some other applications. Okay, this way in the 6 to 7 sectors, the powder metallurgy components can be used. Okay, so in this way this powder metallurgy chapter is completed. Okay, now I will summarize it, what we have learned in this powder metallurgy chapter. Okay, for we have started this powder metallurgy chapter with the concept of the powder metallurgy. What is the meaning of this powder metallurgy? Okay, I will take to that slides. Okay, I will now we have started with this what is the meaning of powder metallurgy. Okay, what is the meaning of powder metallurgy? Then we have gone through the different steps in the manufacturing of the component using this powder metallurgy technique. And then we have seen these different types of the powder production methods or different methods which are used for manufacturing of the different powders. Okay, now after this we have seen some common applications to manufacture these components. Okay, and that we have seen manufacturing of the three components. Okay, in that we have discussed the manufacturing of the self-lubricating bearing and flow chart involved in it. And after that we have discussed the friction materials manufacturing and its flow chart, then manufacturing of the cemented carbide cutting tool, various steps along with the flow chart. And after this we have completed the remaining point, that is the only to in the today's lecture we have finished that point. Okay, advantages of powder metallurgy process, advantages, then disadvantages and applications in the different sectors. Okay, In this way, this chapter is completed. If you are having any query related to this chapter, you can ask me. Okay, please ask me any queries if you are having any queries related to this chapter. If you are not having any query, kindly mention that in the chat box so that we can stop here, or we will start the next chapter today only. Okay, please give me some reply in the chat box. Can I start the next chapter today only, or we can start it from the next lecture? Am I audible? Please provide me reply. Prajwal, are you there? Prajwal, then any other person is there?
Yes, sir.
And can I start the next chapter today only, or we will start it from next lecture?
Next lecture, sir.
Okay, okay. Okay, maybe I think some due to that location only, we have faced that issue related to my voice. Okay, I will take care from next lecture onwards. Or some network issue is there in this area. Okay, now in this way, I think we have completed this chapter, powder metallurgy, and the concept of the powder metallurgy, how to manufacture a component using that powder metallurgy, different stages involved in it, and its advantages, disadvantages, applications, and manufacturing of some components with various stages along with their flow charts. Okay, we have discussed that. Okay, in this way, we have completed this powder metallurgy chapter. Now, in this way, the 5 chapters have completed out of 6. Okay, 5 chapters I have completed. Only one last chapter is there. Destructive testing and non-destructive testing methods. Maximum 6 lectures will be required, 5 to 6 lectures for complete that chapter. Okay, I think probably in this week only I will try to complete it. Okay, now I will stop here. You can join the your remaining sessions. Okay, tomorrow we will start the destructive and non-destructive testing methods. Okay, thank you. I will stop here.